Imagine waking up one morning and the sun is gone. No sunrise, no warmth, just endless darkness. It sounds like the end of everything, but surprisingly, the sun won't simply disappear. Instead, it will die a slow, spectacular death over billions of years. And when it finally happens, Earth will already be long gone. So what actually happens after the sun dies? Let's travel nearly 8 billion years into the future and witness the final fate of our star. Right now, the sun is about 4.6 billion years old, roughly halfway through its life. Every second, it fuses about 600 million tons of hydrogen into helium, creating the energy that powers every plant, animal, and civilization on Earth. But stars don't burn forever. Eventually, the sun will run out of hydrogen in its core. Without enough fuel, gravity begins crushing the core inward. At the same time, the sun's outer layers expand dramatically. It transforms into a red giant. The once friendly yellow star becomes hundreds of times larger than it is today. Mercury disappears first, then Venus, and eventually, Earth. Whether our planet is swallowed whole or scorched into a lifeless rock, life will have vanished long before then. The oceans will boil away, the atmosphere will disappear. Our world becomes a barren reminder that even planets have expiration dates. Here's something surprising. The sun will not explode as a supernova. It's simply not massive enough. Instead, after the red giant phase, something even more beautiful happens. The sun gently sheds its outer layers into space. These glowing clouds of gas create what's called a planetary nebula, despite having nothing to do with planets. For tens of thousands of years, these colorful clouds shine across space like a giant cosmic flower. Inside the center remains the sun's exposed core. It's called a white dwarf. Although it's only about the size of Earth, it still contains roughly half the sun's original mass. Imagine squeezing the mass of hundreds of thousands of Earths into a sphere no larger than our planet. 1 teaspoon of white dwarf material would weigh several tons. The white dwarf no longer creates energy. It simply glows from leftover heat. Over trillions of years, it slowly cools, dimmer, colder, darker. Eventually, it becomes something scientists call a black dwarf. Here's the incredible part. The universe isn't even old enough for one to exist yet. Scientists estimate it would take far longer than the current age of the universe for a white dwarf to cool completely. That means no black dwarfs exist anywhere in the cosmos. At least, not yet. Long after humanity is gone, long after galaxies collide, long after most stars have burned out, the tiny remnant of our sun may finally fade into complete darkness. If humans still exist billions of years from now, we almost certainly won't be living on Earth. Civilizations may have spread across the solar system, or even to entirely different stars. By the time the sun becomes dangerous, our descendants could already be living beneath alien skies. To them, our dying sun might simply become another bright object remembered in history books, the birthplace of humanity, a star that gave life, before quietly fading away. The death of the sun isn't just the end of a star. It's a reminder that nothing in the universe lasts forever. Not planets, not stars, not even galaxies. Yet somehow, that's what makes our tiny moment in cosmic history so extraordinary. For now, the sun still has billions of years left to shine. Every sunrise you see is powered by a star that's been burning for nearly 5 billion years and will continue long after every person alive today is gone. So maybe the real question isn't what happens after the sun dies. It's what humanity chooses to do before that day ever arrives. If you enjoyed exploring the future of our universe, don't forget to like the video, subscribe to the channel, and let me know in the comments. What space mystery should we explore next? Thanks for watching, and I'll see you in the next one.